Let's discuss a question from strength of materials. You have a thin pressure vessel given. So when you have a thin pressure vessel, okay, and when you have, let's say, a closed pressure vessel, pressure is acting on all the sides. So then if you take a element on the periphery, okay, you have the hoop stress, which is the circumferential stress, and the longitudinal stress. And the formula is, after derivation for the hoop stress, is PD by 2T, and longitudinal is PD by 4T. So go for the same PD and T, where P is pressure, D is diameter, and T is thickness. This is more, right? This is the thing. So if you look at the element, this is your circumferential and this is your longitudinal. So obviously when you have this is a plane stress kind of problem where you have only two normal stresses, and the maximum of that will be your principal stresses. So principal stresses in this problem will be sigma c, because that's the maximum, and sigma p2 will be your longitudinal. So we take this stress in our design because that is the maximum stress. So the maximum tensile stress has to be limited to 9000. So PD by 2T, which is your circumferential stress or the hoop stress, has to be 9000 Newton per mm square, Newton per meter square, sorry. Okay. So pressure is given as 500. Everything in this we substitute in meters. Diameter is given as 0.6. Thickness is something which I don't know, so you have to limit this to 9000. Okay, so the thickness part the thickness has to be greater than, from this equation what we can write is 5000 into 0.6 by 2 into 500, okay, by 9000. So that means thickness is 500, so that is 5 by 180 basically into 0.6. so this, if we calculate, we get this is like how much, this is 0.3, so it's basically 1 by 600, right? 1 by 600 is something which you get it, because the top one is 0.3, so it's 3 by 1800, that's 1 by 600, and 1 by 6 it's 0.166, okay, and two zeros. So right, so this is in meters, remember, but so the minimum thickness is 1 by 600 meters, and if I convert that into mm, so it's 1000, 1 meter is 1000 mm, and so I get about 10 by 6, which is 1.67 meters, 1.67 mm. So it got to be 1.67 mm. Okay, so let's just look at the calculations again. So this is so 0.3 and 0.3, so 3 by 1800. This is not 0.3, 5 into 0.6 is 3 by 80, so this is 1 by 60, and so 1 by 60, so let's just write down here. Okay, T, what we get is 1 by 60 meters, and so the minimum T which is possible is 1 by 60 meters, and meters when you convert into mm, it's 1000 mm. Okay, so this is 100 by 6, 100 by 6 is 16.666, so 16.67 mm. So that is the thing. Okay, this is, I think we just wrongly took, so you have to just go in this way. So 16.67 mm is the minimum thickness that has to be there, so that your hoop stress doesn't cross the 9000 Newton meter square. So 16.67 mm is the answer. Thank you.